The date was March 1944, and the skies over England were a solid grey, rolling in from the Channel like a steel blanket. At RAF Ludford Magna, the morning was tense, the air heavy with anticipation and the faint scent of aviation fuel. Inside the briefing room, Major Thomas Hitchcock, a veteran of the First World War at 53 years of age, leaned over a large map sprawled across the table. Red pins marked deep German industrial targets. Berlin, Leipzig, Magdeburg. Hitchcock's eyes, tired yet sharp, traced the lines between England and these distant cities, calculating risks and losses. The 8th Air Force faced a dilemma that had grown more urgent with each passing month. Allied bombers could reach Germany, but the return journey was another story entirely. Fighter escorts, vital for bomber survival, lacked the necessary range to accompany formations on the long flight home. The P-47 Thunderbolts and P-38 Lightnings, brave and reliable aircraft, though they were, could only travel a few hundred miles before fuel forced them to turn back, leaving bombers vulnerable to enemy interception. Berlin, lying over 570 miles from England, was beyond even the extended capabilities of these fighters. Every mission was a gamble, and the odds were stacked against the bomber crews on the return leg, facing flak, engine failures, and relentless Luftwaffe attacks. Hitchcock had studied the statistics obsessively. He had seen mission after mission end in tragedy, watched the numbers of aircraft and airmen disappear into the clouds, and understood that if a solution was not found, the scale of losses would be catastrophic. "What we need," he told the group of air officers assembled around the map, "is a fighter that can go there and come back." His tone was deliberate, commanding attention, each word weighted with the knowledge of lives dependent upon action and innovation. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. Far to the west, in the bustling design halls of North American aviation, the problem took a different form. Edgar Schmood, the lead aerodynamics engineer, was hunched over a drawing board cluttered with sketches of the Mustang's wings. At 39 years of age, Schmood had spent decades studying airflow, lift, and drag. Yet this problem presented a challenge unlike any before. The XP-51 Mustang had already demonstrated remarkable aerodynamic efficiency, its laminar flow wings slicing through air with minimal drag, but fuel capacity limited its operational range severely. Schmood had proposed a radical solution: integrate fuel tanks directly into the wings themselves. The idea seemed preposterous to his colleagues, some of whom were seasoned engineers with decades of experience in conventional aircraft design. "You can't put that much fuel in the presses, wings," one argued, shaking his head. "It will compromise structural integrity. The plane will fail," another muttered. "Ridiculous. There is no way a single-engine fighter can fly that far." Schmood ignored the skepticism. To him, the calculations were precise, the engineering feasible. The wing tanks were not a frivolous experiment. They were the only method to extend the Mustang's range sufficiently to escort bombers all the way to Berlin and back, and they might very well change the course of the air war in Europe. Prototype testing began in late 1942. The Mustang, now fitted with the Packard-built Merlin engine under license from Rolls-Royce, had transformed from a low-altitude fighter into an aircraft capable of high-altitude efficiency. The Merlin engine, a two-stage, two-speed supercharged power plant, allowed the Mustang to maintain performance at altitudes exceeding 30,000 feet, precisely where bomber escort missions required them to operate. Yet, even with this new engine, the standard internal fuel tanks provided insufficient range. Schmood's wing tanks promised an additional hundreds of miles, potentially enough for a full round-trip mission to Berlin. Engineers ran calculations repeatedly, considering weight distribution, the dynamics of fuel sloshing, and aerodynamic drag. Each variable was meticulously charted, every contingency analyzed. Because failure was not an option. The risk was enormous, the margin for error razor-thin. If the tanks leaked, ruptured, or caused instability, Pilots could be lost over enemy territory, yet the gamble was necessary. The design team pressed forward, producing prototypes of pressed steel tanks, complete with internal baffles to prevent fuel from shifting dangerously during maneuvers, and self-sealing linings to withstand potential battle damage. The first tanks, weighing 420 pounds empty and nearly 900 pounds full, were clamped beneath the Mustang's wings, a visible testament to audacity and innovation. Test pilots approached the first flights with both awe and trepidation. The aircraft took off slowly, laboring under the extra weight. Its climb rate diminished initially, but once at altitude, the Mustang stabilized. Pilots discovered that careful management of internal fuel and drop tanks allowed them to maximize range without sacrificing performance or safety. The procedure was precise. Take off with fully fueled tanks, climb to cruise altitude using only internal fuel, switch to drop tanks mid-flight, and jettison them before combat to restore full maneuverability. Flight manuals, initially dismissed as theoretical, became critical guides for these pilots, who would soon test the aircraft in real combat over the heart of Nazi Germany. By March 1944, the 354th Fighter Group was stationed at RAF Boxted, ready to test the new capabilities in battle. The pilots, a mix of veterans and rookies, were briefed on the extraordinary mission: escort heavy bombers deep into German territory, a task previously considered impossible. Among them was Lieutenant James Caldwell, 27, a meticulous navigator who had flown dozens of escort missions but had never attempted one to Berlin and back. He studied the maps carefully, calculating fuel consumption, estimated headwinds, and potential points of Luftwaffe interception. Each pilot understood the stakes. The Mustang's innovative wing tanks were the only reason this mission could be attempted with any hope of success. If they failed, bomber losses could be catastrophic, and hundreds of airmen would not return home. The night before the mission, Caldwell sat alone in the hangar, running through every calculation in his mind. The tanks, fully loaded, added over 1,800 pounds to the aircraft. Takeoff would be longer, initial climb slower, and maneuverability reduced until the tanks were depleted or jettisoned. But he also understood the promise. Once in combat, the range provided by the wing tanks could allow continuous escort over 1,650 miles, ensuring that bombers would have protection all the way to Berlin and back, invalidating enemy assumptions about fighter limitations. The Luftwaffe had grown accustomed to attacking bombers during the return leg, counting on escort fighters to turn back once fuel ran low. The Mustang, with its wing tanks, would defy that expectation entirely. The following morning, the Mustangs lined up along the runway under grey skies. Engines roared as the pilots performed final checks, the Merlin engines throbbing with steady power. The weight of the drop tanks caused the aircraft to sag slightly on the landing gear, but once airborne, the Mustangs climbed with precision. Formation flying required meticulous attention. The additional weight altered handling, making small corrections necessary to maintain alignment with the bombers below. Every pilot had to monitor fuel flow, engine temperature, and airspeed. Any error could compromise the entire mission. As the aircraft crossed the channel, the drop tanks carried enough fuel to maintain flight for hours. The pilots calculated cruise speeds that would optimize fuel consumption without compromising the ability to respond to enemy fighters. The mathematical precision of the flight plan was as critical as any weapon carried on board. Radio silence was maintained to avoid detection, and the bombers followed predetermined headings, relying on navigators to guide them across hostile skies. The real test came as the formation approached the German border. Spotters on the ground had already identified bomber columns, and Luftwaffe controllers scrambled interceptors in anticipation of the attack. German doctrine dictated that fighters would engage only after the escorting planes turned back. The Mustangs, however, maintained full escort formation, proving the calculations and engineering soundness of the wing tanks. Enemy pilots, upon sighting the American fighters still at full strength, were forced to reconsider their tactics. Confusion spread rapidly among the Luftwaffe, whose pilots had never encountered single-engine aircraft capable of such range. The appearance of the Mustangs above Berlin marked a turning point. For the first time, bomber formations were protected throughout the entirety of their mission, dramatically reducing losses and inflicting confusion on German Air Defense Command. The psychological impact on the enemy was profound. Pilots who expected unescorted bombers found themselves facing silver Mustangs positioned strategically to counter every attack. One German pilot, later interrogated, recounted the shock. He had been prepared to engage stragglers, yet the P-51 seconds were still present, fully armed and combat-ready. The mathematics of range, previously considered a limitation, had been overcome through innovative engineering, rigorous calculations, and daring execution. The wing tanks, once dismissed as a ridiculous idea, had rewritten the rules of aerial warfare. As the mission progressed, pilots became acutely aware of the operational limits. The drop tanks were jettisoned at the edge of the combat zone to restore agility for dogfights. Machine guns roared as German fighters attempted interceptions, but the Mustang's combination of speed, altitude, advantage, and extended range allowed them to shield the bombers effectively. Every maneuver, every burst of gunfire, relied on careful fuel management and precise coordination between pilots. By the time the bombers had released their payloads over Berlin and began the return flight, the wing tanks had demonstrated their value beyond theory. They had provided the strategic advantage necessary to ensure the survival of the bomber crews. On the return leg, pilots adjusted throttle settings to conserve remaining fuel in the internal tanks. Calculations had been verified, repeatedly. The Mustangs could make the 570-mile flight back to England with minimal risk. The exhilaration among the pilots was tempered by the reality that success required sustained attention and discipline. One miscalculation could strand an aircraft over hostile territory. Yet the plan held, and the bomber formations began to move safely home under the protective umbrella of the Mustangs. The first operational mission using the wing tanks concluded with remarkable success. Losses were significantly lower than previous deep penetration raids, and the Luftwaffe's defensive doctrine was undermined. Commanders in London realized the potential immediately. With the new wing tank configuration, strategic bomber raids could penetrate further into Germany with reliable escort, altering the balance of the air war over Europe. Edgar Schmood's ridiculous idea had not only worked, it had revolutionized aerial strategy. In the weeks following, further missions refined tactics for drop tank usage. Pilots learned optimal cruising speeds, altitudes for fuel efficiency, and protocols for jettisoning tanks to maximize combat readiness. The Mustang, previously considered a limited-range fighter, had become an unmatched long-range escort, capable of protecting bombers on missions previously deemed impossible. Engineers continued to improve the design, incorporating lessons learned from each sortie, while pilots developed instinctive understanding of the aircraft's new capabilities. The combination of precise engineering, careful planning, and courageous execution proved decisive. By the end of March 1944, the P-51 Mustang with integrated wing tanks had secured its place in history. Allied bomber formations could reach Berlin and return with full fighter support, effectively neutralizing previous Luftwaffe advantages. The air war over Germany shifted dramatically, with American pilots now able to project power deep into enemy territory. The ridiculous innovation that had once been doubted became the foundation of a new era in strategic bombing, demonstrating the transformative power of engineering when paired with vision and courage. The Mustang, sleek and silver, with its hidden reservoirs of fuel, had changed the rules of engagement. Its wings carried not only fuel but the promise of survival, the strategy of dominance, and the hope of a faster end to the war. October 1943 marked a turning point in the evolution of the P-51 Mustang. The first Merlin-powered P-51Bs rolled off the production line at North American Aviation with a hum of anticipation, their sleek silver fuselages glinting under the early autumn sun. Engineers, their faces streaked with oil and sweat, watched as the ridiculous aircraft they had designed prepared for its first true test. The Mustang had already impressed with its laminar flow wings, cutting air cleanly and efficiently, but the addition of fuel-carrying wing tanks remained controversial. The wings, once considered too thin and delicate for extra fuel, now housed 2 drop tanks, each capable of holding 110 gallons of high-octane aviation fuel. When full, each tank weighed over 900 pounds, significantly increasing takeoff weight and altering flight dynamics. Some doubted the plane could even leave the ground safely. Yet there it was, engines purring, ready to prove its worth. Test pilots climbed into the cockpits, oxygen masks sealing against the cold, the muffled roar of the Rolls-Royce Merlin engine vibrating through the airframe. Among them was Lieutenant James Caldwell, 27 years old, who had flown P-47 Thunderbolts on countless escort missions, but had never attempted a journey of this magnitude. He checked every dial, tested every control surface, and listened for the telltale hums and vibrations that might indicate structural failure. The ground crew held their breath as the Mustang rolled forward, tires biting into the tarmac, propeller slicing the air. When the aircraft lifted, the initial climb was slow, heavier than usual, requiring precise throttle adjustments to maintain stability. Every pilot knew that a miscalculation could send the plane tumbling into a field, or, worse, into the sea during a cross-channel test flight. The wings flexed visibly under the weight of the tanks, a subtle but constant reminder of the gamble they were undertaking. Once at altitude, the Mustang revealed its true potential. The Merlin engine, a 2-stage, 2-speed supercharged marvel of engineering, performed flawlessly, maintaining power at altitudes above 30,000 feet. The aircraft, now stable in level flight, allowed pilots to concentrate on the most critical aspect of the mission: fuel management. Internal fuel was used first to climb and maneuver efficiently, reserving the drop tanks for cruising at altitude and long-range segments. Switching between tanks required precise timing, careful observation of fuel flow meters, and constant awareness of wind and atmospheric conditions. Pilots practiced these transitions repeatedly, as even a brief mismanagement could reduce the aircraft's effective range and imperil both the pilot and the bombers they were sworn to protect. Flight officers began to treat fuel management as both science and art, a literal calculation of survival over hostile territory. Charts, tables, and logs were meticulously maintained, tracking consumption rates under varying altitudes, speeds, and maneuvers. The early flights proved the concept viable, though not without tension. By March 1944, the 354th Fighter Group was fully equipped and stationed at RAF Boxted, ready to execute the first operational missions with Merlin-powered Mustangs carrying fully integrated wing tanks. Briefings emphasized that the mission's stakes were unprecedented. Bomber formations, primarily Boeing B-17 Flying Fortresses, consolidated B-24 Liberators, would strike deep into the heart of Germany, aiming for factories, rail yards, and munitions plants in Berlin and surrounding regions. The challenge was not merely reaching the target, but ensuring the bombers' safe return. Escort fighters were to fly from England to the target and back without refueling, a feat previously considered impossible for single-engine aircraft. For the pilots, the flights represented both exhilaration and terror. They had trained for combat, but never for endurance missions of this length. They knew that a failure in fuel calculations or wing tank performance could mean abandonment over enemy territory, with little hope of rescue. Among the pilots, Captain au Beleton Franz Stigler, flying a German Focke-Wulf U-190, was stationed across enemy lines, unaware that the very rules of engagement he had long relied upon were about to be overturned. Luftwaffe doctrine had trained pilots to expect American escort fighters to turn back, after several hundred miles, leaving bomber formations vulnerable on the homeward leg. Stigler had executed this tactic dozens of times, intercepting stragglers and crippling bomber groups. Yet this time, as the P-51 seconds appeared over Berlin at 28,000 feet, fully capable and with fuel gauges still reading hundreds of miles of remaining range, everything he knew about aerial combat seemed suddenly invalid. German pilots struggled to reconcile what they saw with their understanding of physics and engineering. Single-engine fighters simply were not supposed to make this journey, yet here they were, slicing between the bombers, their Merlin engines humming, wings glinting in the sun, fully capable of engaging in combat. The ridiculous wing tanks had delivered the impossible, defying every assumption of range and endurance held by enemy forces. The flight formations themselves became a testament to planning, precision, and courage. Mustangs flew in tight, echelon formations, their pilots trained to anticipate one another's movements and maintain protective coverage over the bomber groups below. Communication was a delicate dance of coded radio messages, hand signals, and visual cues. At these altitudes, every maneuver altered fuel consumption rates, and pilots had to constantly adjust throttle, climb angle, and airspeed to optimize the use of wing tank reserves. Drop tanks were monitored meticulously. Once near empty, pilots were trained to jettison them instantly, restoring full agility for dogfights. Misjudgment could result in wing tanks rupturing mid-combat, a catastrophic hazard that could compromise the aircraft and jeopardize the entire formation. The level of discipline required was extraordinary, a combination of nerves, skill, and absolute trust in both machine and fellow pilots. The significance of these flights extended far beyond engineering success. Operationally, they represented a paradigm shift in the air war over Europe. Previously, bomber losses on deep penetration raids could reach 5 to 10%, primarily because escorts were forced to turn back before the return leg. Now, with wing tanks extending the P-51's range to over 1,650 miles, bomber crews could count on protection from takeoff to landing. The Luftwaffe, trained to exploit predictable patterns, now faced an adversary capable of constant coverage. German pilots attempting to intercept bombers were often met by Mustangs that could climb, dive, and maneuver with full combat capability, even after hundreds of miles of continuous flight. This forced the enemy to revise their tactics, reconsider engagement points, and contend with a threat that existed where none had been expected. The appearance of P-51 seconds above Berlin fundamentally altered Luftwaffe calculations. For the American pilots, each mission brought a mix of exhilaration and calculated fear. The first operational flight of the Merlin-powered Mustangs demonstrated that the wing tanks functioned not only as fuel reservoirs, but as instruments of psychological warfare. Pilots felt the unique sensation of flying farther than ever before, the thrill of endurance matched by the responsibility of protecting hundreds of lives below. Many wrote in letters home about the awe-inspiring experience of seeing Berlin from above, a city they had only studied in maps and intelligence reports. They observed its sprawling factories, smoke rising from chimneys, and the precise formations of German anti-aircraft emplacements. Despite the danger, there was a strange sense of accomplishment. The ridiculous innovation they had flown had now proven itself indispensable. The wing tanks themselves became artifacts of engineering brilliance. Crafted from pressed steel with internal baffles to prevent fuel sloshing, they were self-sealing to withstand potential battle damage and able to operate at temperatures as low as -50 degrees Fahrenheit. Their attachment mechanisms were simple yet reliable, allowing pilots to jettison them quickly when combat was imminent. Each tank cost approximately $18 to manufacture, a small price for the strategic advantage they provided. Engineers had tested hundreds of variations, considering structural integrity, aerodynamic drag, and weight distribution. The result was an aircraft capable of unprecedented range without compromising maneuverability or combat effectiveness. As missions continued in the spring of 1944, the 354th Fighter Group honed techniques for maximum efficiency. Pilots learned optimal cruising speeds, the precise altitudes to switch between fuel sources, and the timing for jettisoning drop tanks. Flight manuals were updated to reflect new best practices, and training regimens incorporated these lessons for every pilot joining the squadron. The Mustang's combination of low-drag laminar flow wings, the high-altitude power of the Merlin engine, and the additional fuel from wing tanks created a fighter capable of escorting bombers on missions that had once been considered impossible. By the time the first full-scale raid over Berlin was completed, the P-51 had proved that endurance, engineering, and daring could combine to change the strategic balance in the air. Even German pilots could not ignore the implications. Interrogations conducted after these missions revealed a sense of disbelief and frustration among Luftwaffe crews. Pilots reported that the Mustangs remained with bombers throughout attacks, their fuel seemingly inexhaustible, undermining established tactics based on predictable escort limitations. For many, the realization was stark. American engineering had created a fighter that could project power across unprecedented distances, rendering previous assumptions about range and attrition invalid. The strategic consequences were enormous. Bomber crews, once resigned to peril on the return leg, now had hope of surviving deep penetration missions. Commanders could plan strikes further into Germany, secure in the knowledge that escort coverage would remain reliable. In the months following the first flights, additional refinements were implemented. Pilots were trained in fuel conservation techniques, optimal climb profiles, and coordinated attack patterns to maximize efficiency. Wing tank design was standardized, allowing rapid production and replacement. The P-51's range became a critical factor in the planning of every major bombing campaign, and the aircraft's reliability instilled confidence in both pilots and commanders. The psychological effect on the enemy cannot be overstated. German fighters could no longer expect to engage unescorted bombers, forcing a complete rethinking of air defense strategy. By the end of March 1944, the first operational missions of wing tank-equipped Mustangs had succeeded beyond expectation. Bombers reached Berlin and returned safely, under continuous escort. Losses, previously estimated to be devastating, were significantly reduced. The ridiculous idea that had seemed impossible, that had drawn skepticism and laughter from engineers and commanders alike, had become a cornerstone of Allied air strategy. It was a triumph not only of design but of vision, risk-taking, and human ingenuity. The Mustang, with its silver fuselage glinting against the dawn sky and wings carrying hidden reservoirs of fuel, had become more than an aircraft. It was a symbol of possibility, a testament to the idea that innovation could challenge and overcome conventional limitations. Pilots like James Caldwell, along with the rest of the 354th Fighter Group, had flown farther than anyone thought possible, their lives intertwined with the precision of engineering and the courage of human spirit. Each mission reinforced the lesson that careful planning, disciplined execution, and bold imagination could reshape the battlefield. The wing, tanks, once ridiculed, now represented the future of air combat, an era where distance and endurance were no longer insurmountable obstacles, and where single-engine fighters could achieve what had once been deemed impossible. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. March 6, 1944, 1,347 hours. The English countryside stretched beneath the clouds, grey and misted with early spring fog. 800 Allied bombers, a massive armada of Boeing B-17 Flying Fortresses and consolidated B-24 Liberators, rumbled across the skies, their steel frames glinting faintly in the filtered sunlight. Thousands of airmen, men who had trained for months, felt the familiar knot of fear tightening in their stomachs. They had flown missions before, but never one of this magnitude. Flak positions bristled across the Ruhr Valley, and the Luftwaffe waited above, eyes sharp, and guns ready. Losses on missions into Germany were already measured in double digits, and without proper escort, the numbers could climb even higher. From the horizon, a formation of silver P-51 Mustangs appeared, their sleek lines cutting the sky like polished knives. Pilots of the 354th Fighter Group gripped their control sticks, eyes scanning, ears tuned to the hum of the Rolls-Royce Merlin engines beneath their cowlings. Each aircraft carried 6 50-caliber machine guns, deadly enough to shred enemy fighters, and 2 external drop tanks, fully loaded with 110 gallons each. The extra weight, over 1,800 pounds, affected the aircraft's climb rate and maneuverability, requiring precise handling. Pilots knew that the first hour of the mission demanded caution, conserving energy and fuel while maintaining altitude. They switched between internal and external fuel sources meticulously, a process honed over countless training sorties, balancing range and agility with every throttle adjustment. Lieutenant James Caldwell, 27 years old, led the initial flight wave, the Mustang's canopy fogged with condensation from his breath. He checked his fuel gauges repeatedly, confirming the drop tank's remaining capacity, while simultaneously scanning the clouded horizon for the first hint of German aircraft. Beside him, Captain Richard Harland, 32, flicked switches and leaned forward, monitoring his instruments. Both men understood the stakes. This flight was the first operational test of the wing tanks in combat, and failure meant the destruction of hundreds of bombers and the loss of irreplaceable crews. Behind them, formations of Mustangs maintained tight coverage over the bomber stream, climbing, diving, and weaving in coordinated patterns to protect the lumbering fortresses below. By the time the formations crossed the Rhine, the bombers had delivered their payloads on ball-bearing factories and industrial centers critical to the German war machine. Smoke rose from the targets, mingling with the clouds, creating a grey tapestry that stretched to the horizon. German fighters, long trained to wait for the American escorts to turn back before engaging, were startled to find the silver Mustangs still present, maintaining altitude, guarding the bombers' flanks. Oberleutnant Vera Schroer, 29, flying a Messerschmitt Bf 109, later described the sight during interrogation. They shouldn't have had enough fuel, yet there they were. Still fighting, still escorting, we could not defend against them. His words would echo in intelligence reports for months, highlighting the confusion and disbelief sown by the unexpected endurance of the Mustang. The effect of the Mustang's presence extended beyond immediate tactical superiority. Luftwaffe doctrine had relied on predictable behavior. Escort fighters would turn back at a specific point, leaving bomber formations exposed on their return leg. The Mustangs invalidated this assumption entirely. German pilots, trained to engage over expected windows of vulnerability, were now forced to fight continuously, altering maneuvers mid-flight and reconsidering every engagement. They had anticipated easy targets, unescorted bombers ripe for interception, but instead encountered agile, persistent, and fully fueled fighters that could not be forced away. The psychological impact was immense. Pilots reported unease and hesitation, unsure whether to engage or retreat, undermining confidence in their own tactics and creating hesitation that American bombers exploited. Flight leaders communicated with tight precision, coordinating attack and defense through a network of radios, hand signals, and visual markers. Each Mustang pilot understood their role in the formation: protect the bombers, intercept enemy fighters, and conserve fuel for the return journey. Maneuvers were calculated, a delicate balance between aggression and prudence. Pilots switched from internal fuel to drop tanks as they reached cruising altitude, optimizing range while maintaining readiness for combat. Drop tanks were jettisoned carefully once depleted or at the first sign of aerial engagement, restoring full maneuverability for dogfighting. Every pilot's skill, every calculation, every subtle adjustment contributed to a mission that tested the limits of engineering, strategy, and human endurance. Captain Oberleutnant Franz Stigler, 31 years old, was flying the Focke-Wulf T-190 on the German side, prepared for his usual tactic: intercept stragglers on the bomber's return leg. He had executed this maneuver dozens of times since late 1942, exploiting the limited range of American escort fighters. Yet, as he approached the formation above Berlin, the familiar assumption shattered. Mustangs were still present, fully operational and capable of immediate response. They flew higher, faster, and longer than doctrine predicted, forcing Stigler to rethink engagement entirely. He recalled the moment in his later debrief. "I expected unescorted bombers, but the Americans remained, flying with full control, confident, and unafraid. It was unlike anything I had seen before." The encounter demonstrated that the technical innovation of wing tanks had translated into a strategic game-changer, capable of shaping entire air campaigns. Bomber crews noticed the difference immediately. Airmen peered through waist gunners' ports and cockpit windows, watching the Mustangs maintain formation above and alongside. The reassurance was palpable. Previously, crossing deep into German territory carried a constant dread of enemy fighters striking after escort turned back. Now, pilots and crew could concentrate on navigation, bombing accuracy, and maintaining formation rather than fearing the inevitable ambush. Morale soared, and confidence in mission success increased with every mile traveled under continuous cover. The combination of Merlin engines and wing tanks enabled Mustangs to remain fully armed and operational, ensuring protection throughout the journey. The technical sophistication behind the wing tanks required careful attention from engineers and pilots alike. Pressed steel tanks with internal baffles prevented dangerous fuel sloshing that could destabilize the aircraft at high speeds or during sharp turns. Self-sealing layers offered protection from small-caliber rounds, while attachment mechanisms allowed pilots to jettison tanks instantly. Each tank cost roughly $18 to manufacture, a minor expense for the strategic advantage provided. Engineers monitored every aspect, from aerodynamics to weight distribution, conducting repeated tests to confirm the aircraft's resilience and performance. Pilots were briefed extensively on the operational limits of the tanks, learning to anticipate fuel behavior under extreme conditions, including temperatures that dropped as low as -50 degrees Fahrenheit at high altitudes. As the mission progressed, German fighters attempted to engage the bomber formation multiple times. Messerschmitts and Focke-Wulfs dove from above and below, seeking weaknesses in defensive positioning. Mustang pilots responded with disciplined coordination, intercepting attackers with precision bursts from their .50 caliber machine guns. Several enemy aircraft were destroyed or forced away, while bomber losses remained minimal. The mission highlighted not only the P-51's extended range, but also its versatility as a high-altitude escort fighter. Fuel reserves, careful planning, and disciplined execution combined to neutralize the threat, proving the concept of integrated wing tanks as a decisive factor in air superiority. Throughout the flight, radio chatter reflected both relief and tension. Pilots shared updates on fuel consumption, enemy sightings, and bomber integrity, creating a real-time map of operational awareness. Lieutenant Caldwell noted in his flight log that fuel management was as critical as target acquisition or gunnery. "We fly not just with guns and engines, but with gallons of fuel in every maneuver. One miscalculation, and the mission is lost." The integration of technical skill and strategic judgment exemplified the new era of long-range air operations. Each pilot became both engineer and tactician, aware that endurance and firepower were inseparable in achieving mission objectives. By the time the bombers began their return journey, the Mustangs remained with them, engines humming with controlled power, drop tanks empty and jettisoned to regain full agility. Pilots maintained altitude, coordinated positions, and intercepted remaining enemy aircraft. The journey back over German territory, once considered the most dangerous segment of deep penetration missions, was now manageable, albeit still tense. Crew members aboard the bombers observed the silver Mustangs above, their presence both comforting and awe-inspiring. They realized that these aircraft, once derided as ridiculous, were now the defining factor in survival and operational success. German pilots, caught in repeated engagements and confronted with an escort that defied established doctrine, faced frustration and confusion. Oberleutnant Schroer later reported the effect on morale and tactics. "Our formations faltered. We were trained to wait for the American fighters to turn back. When they did not, it changed everything. We were hesitant, uncertain. The Americans flew farther than we thought possible and remained effective." This psychological shift contributed as much to the success of the mission as the physical destruction of enemy aircraft. The P-51's extended range and combat capability effectively rewrote the rules of aerial warfare over Germany, demonstrating that innovation in design could dictate the terms of engagement. On landing, pilots and crews were exhausted but exhilarated. The first operational escort mission with wing tank-equipped Mustangs had been a resounding success. Bombers returned largely intact, losses were dramatically lower than historical averages, and pilots had demonstrated both endurance and precision in combat. The innovation that had seemed so improbable, so ridiculous in its conception, had not only worked but had fundamentally changed the dynamics of the air war over Europe. Officers debriefed crews, recording every detail of fuel management, enemy encounters, and formation performance, ensuring that lessons learned would guide future missions. The success of March 6, 1944, extended far beyond a single day. The mission validated the design philosophy of integrating fuel into the wings, proving that single-engine fighters could now escort bombers across the entirety of Germany and return safely. Allied strategic planners adjusted campaign tactics to exploit this newfound capability, permitting deeper strikes into the Reich with confidence in the reliability of escort coverage. The P-51's extended range forced the Luftwaffe to reconsider the timing and placement of their fighter defenses, undermining entrenched assumptions and providing American bombers with unprecedented operational freedom. As pilots wrote letters home, many included sketches of the Mustang's wings, annotated with observations on fuel flow, climb rates, and maneuverability. The aircraft became a symbol not only of technological achievement but also of human courage and ingenuity. Engineers, who had once been mocked for suggesting wing tanks, finally received recognition for their insight, knowing that their gamble had transformed the aerial battlefield. Across the English airfields, maintenance crews cleaned, inspected, and refueled the Mustangs, aware that these planes were no longer merely fighters, they were instruments of strategic dominance. By nightfall, after the return of all formations, airfields were filled with a quiet, reflective energy. Pilots removed oxygen masks, their faces pale but satisfied. Lieutenant Caldwell wrote in his log, "Today, we flew farther than anyone thought possible, yet we protected lives and struck fear into the enemy. The ridiculous wings carried not just fuel, but the weight of history." The words captured the significance of the mission. Innovation had enabled endurance, endurance had enabled survival, and survival had enabled strategic advantage. The first escort mission had proven that vision and engineering, combined with skill and courage, could achieve what had once seemed impossible. The triumph over enemy air defenses was not the product of luck or coincidence. It was the result of engineering ingenuity, countless hours of calculation, and the relentless determination of designers, mechanics, and test pilots. The P-51 Mustang's ability to escort bombers deep into German territory depended entirely on its extended range, achieved through the innovative use of wing tanks. These tanks were far from simple containers of fuel. They were carefully engineered mechanisms that had to withstand the brutal realities of aerial combat. Every aspect of their design demanded precision. Engineers incorporated self-sealing mechanisms that could automatically close punctures caused by flak or small-caliber rounds, preventing fires that could easily destroy the aircraft at high altitudes. This feature alone required layers of specialized rubber and treated fabrics inside the tanks, a technical challenge that tested both material science and mechanical ingenuity. Pressure management presented another formidable obstacle. At altitudes exceeding 30,000 feet, air pressure drops significantly, and fuel behaves differently under low-pressure conditions. Engineers needed to ensure that fuel would flow consistently from the wing tanks to the engine, preventing vapor lock or starvation during long climbs. Each tank was equipped with venting systems and baffles, designed to regulate fuel pressure, reduce sloshing, and maintain balance, even during steep banking maneuvers. The design process was chaotic, fast, and often dangerous. Early prototypes used paper tanks, which frequently ruptured under stress, resulting in spills and catastrophic fires during testing. Pressed steel tanks eventually became the standard, providing durability without compromising weight distribution. Every tank underwent rigorous testing, from simulated combat conditions to altitude chambers replicating the frigid temperatures above 30,000 feet, sometimes as low as -50 degrees Fahrenheit. Weight distribution was equally critical. The addition of over 1,800 pounds of fuel in the external drop tanks altered the aircraft's center of gravity and aerodynamic profile. Engineers had to calculate the exact placement of each tank, balancing lift, drag, and stability while accounting for changing fuel loads during flight. A miscalculation could lead to stalls, spins, or uncontrollable rolls, particularly during takeoff or evasive maneuvers. Test pilots, men like Lieutenant James Caldwell, 27, and Captain Richard Harland, 32, risked their lives during these trials, pushing aircraft to extreme limits to verify safety margins. Long takeoff runs became standard, initial climb rates were slower, and each maneuver required careful attention to throttle control and bank angles. Every detail mattered. Fuel consumption was calculated with near mathematical precision. Pilots had to consider speed, altitude, wind direction, and formation position. The mathematics of survival left no margin for error. A misjudged throttle setting or a delayed fuel switch could mean ditching over hostile territory or worse. Once in combat, pilots adapted further. The external drop tanks were designed to be jettisoned quickly once depleted or in high-intensity dogfights. This restored full maneuverability, allowing the Mustang to engage enemy aircraft with the agility of a lightweight fighter. Pilots learned to time jettisoning with the rhythm of combat, ensuring they had fuel for both the fight and the long return journey. Internal fuel remained sufficient for hundreds of additional miles, giving the aircraft an operational radius unmatched by contemporary designs. By the time the first combat escort missions were conducted, the integration of wing tanks had become second nature to the 354th Fighter Group. Every maneuver, from tight turns to high-altitude climbs, reflected a balance of technical knowledge and instinct honed through rigorous training. The strategic implications of the wing tanks were monumental. A single-engine fighter capable of escorting bombers 1,650 miles round trip had previously been considered impossible. Standard doctrine held that fighters could only operate a few hundred miles from base, forcing bomber crews to fly dangerous return legs unprotected. Edgar Schmood, the engineer who championed the concept of integrated fuel tanks in the Mustang's wings, had been labelled ridiculous by many of his colleagues. Yet the realization of his vision now defined the Allied air campaign over Europe. Bombers, once forced to confront enemy territory alone, now had constant protection from fighters capable of staying with them from takeoff to return, dramatically reducing losses. Intelligence reports later confirmed that Luftwaffe pilots were stunned by the presence of Mustangs at altitudes and distances previously thought unreachable. The operational use of wing tanks required meticulous planning. Mission briefings extended beyond target coordinates and enemy fighter intelligence to include precise calculations of fuel loads, drop tank release schedules, and contingency plans for emergency landings. Pilots had to memorize the capacities of their internal and external tanks, switching at specific altitudes and throttle settings. The process demanded both mental acuity and practical skill. Mistakes could be fatal. Yet, when executed correctly, the results were astonishing. Mustangs maintained formation with bombers deep inside enemy territory, engaged hostile fighters, and returned with ample fuel reserves, a feat previously unimaginable. Crews aboard bombers reported a new sense of confidence, no longer anticipating abandonment during the perilous final miles of their mission. Maintenance crews played an equally vital role in the triumph of wing tanks. After each sortie, tanks were inspected for leaks, damage, and pressure integrity. Crews learned to repair minor punctures swiftly, often working in freezing temperatures while rain or snow fell across airfields in England and France. Ground personnel became experts in fuel chemistry, understanding how temperature, altitude, and pressure affected flow rates. Each aircraft's operational readiness depended on flawless execution both in the air and on the ground. The seamless coordination between engineers, pilots, and mechanics became a hallmark of the Mustang program, exemplifying the integration of human skill and technological innovation. The psychological effect on Allied airmen was profound. Once reliant on luck and limited fighter coverage, bomber crews could now trust in the presence of P-51 seconds. They observed the silver Mustangs gliding above, engines steady and guns ready, and felt a renewed sense of security. The reduction in losses during deep penetration raids reinforced the belief that engineering innovation could directly save lives. Letters sent home from airmen described both awe and gratitude, emphasizing the reliability and endurance of the aircraft. Many included sketches of wing tanks and notes on fuel management, demonstrating the pride pilots took in participating in this technological revolution. Enemy pilots, confronted by the endurance and firepower of wing tank-equipped Mustangs, experienced confusion and hesitation. Messerschmitts and Focke-Wulfs, trained to exploit predictable escort limitations, found themselves continually countered. Oberleutnant Vera Schroer later recounted the psychological strain. "We had expected American fighters to turn back long before deep engagement. When they did not, it altered our calculations, our timing, and our confidence. The presence of Mustangs with unlimited seeming endurance made every engagement uncertain and dangerous. These encounters underscored the strategic advantage provided not by raw numbers, but by engineering solutions that extended operational reach and imposed uncertainty on the enemy. The success of the wing tanks also influenced broader strategic planning. Allied commanders could now plan missions previously considered too risky due to the distance from bases in England. Long-range bombing raids could target industrial centres, oil refineries, and rail hubs deep in Germany with confidence that escort fighters would remain present. The capability reshaped the European air war, forcing German command to reconsider defensive tactics, relocate airfields, and adjust deployment schedules. The integration of engineering innovation and combat strategy demonstrated the synergistic power of human ingenuity when applied with precision and daring. Every technical detail mattered. Engineers calculated center of gravity changes as fuel was consumed, adjusting the position of drop tanks and internal reservoirs. Self-sealing layers were tested against bullets, shrapnel, and simulated flak strikes. Venting systems regulated fuel flow, preventing catastrophic vapor lock during steep climbs or dives. Even minor adjustments in tank attachment mechanisms could alter aircraft balance by several degrees, significantly impacting maneuverability during dogfights. The attention to detail reflected a culture of meticulous problem-solving, born from necessity and honed under pressure. Test. Pilots, having endured months of flights with prototype wing tanks, became instrumental in training operational squadrons. They developed standard operating procedures for fuel management, including recommended throttle settings, altitude profiles, and drop tank release points. Pilots practiced simulated engagements while monitoring fuel depletion, learning to make split-second decisions that balanced combat performance with endurance. By the time the first operational missions commenced, the knowledge gained from testing had been codified into doctrine, ensuring that every Mustang pilot could exploit the aircraft's full potential without unnecessary risk. The Mustang program, particularly the implementation of wing tanks, became a testament to American innovation under duress. It demonstrated how engineering, applied creatively and decisively, could transform the capabilities of a single aircraft to influence the outcome of an entire theatre of war. From the chaotic early days of prototype testing, through grueling combat sorties, to operational dominance over German skies, the journey of the wing tank-equipped P-51 was one of perseverance, ingenuity, and collaboration. The ridiculous idea that Edgar Schmood had championed had become a symbol of what could be achieved when risk was embraced, calculations were precise, and human skill was applied to solve seemingly insurmountable problems. By the end of 1944, the impact was undeniable. Pilots and ground crews had mastered the handling, maintenance, and tactical use of the aircraft. Bomber losses decreased significantly on long-range raids, morale among Allied airmen soared, and the Luftwaffe struggled to adapt to an aircraft that could remain in combat far longer than previously thought possible. The P-51 Mustang, once an untested prototype with innovative wing tanks, had become a linchpin in the air campaign over Europe. Its endurance, reliability, and lethal capability were a direct result of meticulous engineering and calculated risk-taking. Every sortie flown reinforced the lesson that technology, combined with human skill and courage, could redefine the battlefield. Ultimately, the engineering triumph of the wing tanks extended beyond the immediate tactical and strategic advantages. It exemplified the potential of human ingenuity in the face of adversity, illustrating how careful design, rigorous testing, and adaptive tactics could overcome challenges that once seemed insurmountable. The combination of self-sealing mechanisms, pressure management systems, balanced weight distribution, and precise operational procedures ensured that pilots could undertake missions previously thought impossible. The P-51's extended range, the ability to escort bombers 1,650 miles round trip, and the consistent reliability under combat conditions solidified its place in aviation history. What began as a ridiculous idea had transformed into an indispensable tool of Allied air power, saving lives, altering strategic calculations, and demonstrating the enduring power of thoughtful engineering applied with courage and determination. March 6, 1944, marked a decisive turning point in the air war over Europe. The P-51 Mustang, equipped with its innovative wing tanks, had proven itself capable of escorting bombers deep into German territory and back a feat previously deemed impossible. Berlin's skies, once considered beyond reach, were now actively contested. Allied bombers, which had previously endured perilous return flights with minimal protection, now flew under the watchful eyes of silver Mustangs. The Luftwaffe, expecting unescorted formations, suffered significant losses. Over 160 German aircraft were destroyed during the mission, including fighters shot down by P-51 pilots, whose precision and tenacity became the stuff of legend. Bombing efficiency increased as well, since formations lost fewer aircraft, allowing more ordnance to reach industrial centres, ball-bearing factories, and rail hubs. The strategic advantage had decisively shifted to the Allies. German commanders were forced to re-evaluate established doctrines. Their long-held assumption that American fighter escorts would turn back before reaching the heart of Germany had been shattered. Every target, from Berlin to the Ruhr Valley, now lay vulnerable to long-range bombing raids with full fighter protection. The engineers' so-called ridiculous wing tanks had done more than extend operational range. They had changed the very nature of air combat. Pilots, aware of the enormous responsibility and the lives resting on their wings, rose to meet the challenge. Courage, skill, and ingenuity combined with engineering innovation to produce results that neither side had anticipated. From the clouds above Berlin to the skies over the Rhineland, the P-51 Mustang had become not only a tool of Oberth, war, but a symbol of ingenuity prevailing against seemingly insurmountable odds. Years later, Edgar Schmood stood quietly at a small airfield in California, the morning sun glinting off the silver wings of a restored P-51 Mustang as it taxied along the runway. The war had ended over a decade earlier, Europe rebuilt, and the skies above were peaceful, free from the roar of combat. Schmood's mind travelled back to those frantic days of 1943 and 44, when the idea of integrating fuel tanks into the Mustang's wings had been deemed absurd, even reckless. Yet those ridiculous tanks had enabled a single-engine fighter to escort bombers 1,650 miles, allowing crews to strike deep into Germany and return safely. They had saved countless lives and shattered the Luftwaffe's confidence, changing the air war over Europe forever. The Mustang had become more than a machine. It was a testament to human ingenuity, courage, and determination. Each rivet, each polished control surface, spoke of engineers, pilots, and mechanics working against impossible odds. Schmood remembered the engineers hunched over blueprints, calculating drag, weight distribution, and fuel flow with painstaking precision, trusting mathematics and physics where others doubted. He smiled as the Mustang lifted into the clear blue sky, engines roaring, its wings cutting through the air with effortless grace. Ridiculous, they had said. Impossible, they had whispered. Yet here it was, proof that bold ideas, nurtured with skill and courage, could reshape the world. And in that silver flash above the runway, Edgar Schmood saw not just a plane, but a legacy, a symbol that innovation, when paired with daring, can triumph against the unthinkable. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell, so you don't miss any upload from us.